2.6 is going to be a quick video. This is on how to graph a line in slope-intercept form. We've done this before. Remember, slope-intercept form is y equals mx plus b. We know that m tells you the slope, rise over run, and b tells you the y-intercept, that's where to start on this vertical y-axis. All right, kind of broke it down into three different categories. You have these equations that are in slope-intercept form, and then we've got equations that look like y equals a number, and then there's some that look like x equals a number. So let's start with slope-intercept form. That's the first one. And let's do an example like y equals 1/2 x minus 3. Well, we know that the minus 3 is my starting point, so I'd start here at -3. We do not start on the x-axis, all right? We start on the y-axis. And then my rise is 1, and the run is 2. So that means I travel up 1 unit, and then I travel to the right 2 units, 1, 2. And then once I've done that, I can go ahead and I can draw another point. And then I do the same thing. I rise 1 unit, and I run 2 units, 1, 2. And then I can go ahead and make another point. And I typically like to have at least 3 points, just so my line is a little bit more accurate. But once I've got these 3 points, I would take a ruler and I would connect them, and we want to put arrows on the ends, showing that this line does continue forever in both directions. All right. If we have something like y equals a number, all right, if y equals a number, this is always going to be a horizontal line. All right, always a horizontal line. The reason why this is true, well, let's think of an example. Let's think of like y equals, how about 4, okay? If I say that y is 4, what this means is that the y value is always 4, no matter where you're at, right? Well, let's think of where is the graph always 4. Well, I can think of here, the y value is 4, right? That's my height is 4. Well, where else would the y value be 4? Well, here at 1, 4, or 2, 4, or 3, 4, or 4, right? Any of these places, the y value is always equal to 4. So it works out that no matter where I'm at this height, the y value is 4, right? Even if I'm at like 1.5, 4, or 2.1, 4, right? Anywhere along this line here, you're going to have a y value of 4. So that's why y equals a number is always going to give you a horizontal line. Then we have x equals a number, and this is always going to be a vertical line. All right, it's kind of counterintuitive, right? Because we know that y is the vertical axis, but then if we have y equals a number, that line is horizontal. Same thing with this over here. If we've got the x-axis, x is a horizontal axis, but when we graph a line that's x equals a number, that's always going to be vertical. So a little counterintuitive maybe, but if you actually think about it, it should make sense. And so if we say, let's say x equals, how about -2? X equals -2, what this means is I'm looking for where the x value is always -2. Well, I can start to think about this, and I know that the x value here is -2, right? This is -2, 0, -2, 1, -2, 2, -2, 3. So anywhere along this point, right, even in between the values, right, all these decimals, these are all going to be places where the x value is equal to -2. All right, so again, if we start with something like y equals mx plus b, where we have a number in front of the variable, right, notice in slope-intercept form we have the letter y and we have the letter x. So this is going to give us some sort of slope. If we just have y equals a number, there's no slope, right? This is 0 slope. And then if we have x equals a number, this is an undefined slope. So this is just a vertical line. All right, so those are kind of the 3 different types of graphs you'll encounter, and you're expected to know how to graph